Alright, so this is a high performance home that we just completed a rough in on. Went ahead and did one more for the builder. I'm actually not doing any more new construction. It's just I'm not set up for it anymore, and so I won't go into any of those reasons any more than that. But we went ahead and did the one last one because this builder has been really good to us, and we wanted to kind of do another house just to kind of end on a good note. But this entire neighborhood is built by this one builder, and all these houses are about 3,500 square feet, and all of them have 2-ton systems in there, which is pretty incredible tonnage per square feet. This particular house will have a 3-ton system in it because it doesn't have the usual R3 exterior insulation that he normally puts on his house, and he doesn't have the radiant barrier roof sheathing that he normally puts on, just because the supply chains were so messed up, and it just wasn't possible. So that stepped our load up to 3-ton, but normally a house this size would have had a 2-ton. So this is an Energy Star house, and which means that there's a HERS rater that comes back behind us and checks our work, and there are Energy Star points that are added to the house score when certain things are implemented that reduce the power consumption or reduce the load or increase the energy efficiency. And so for this house, it's very important to the builder that we ran all of our ducts in a conditioned space, and that's why he went through great effort to get this open floor or open web truss system put in here. And we, on the front end, when this house was getting drawn and framed up, we got together and tried to figure out where our chases needed to be so that we can run our ducts. So good coordination allowed for ducts to be ran in the conditioned space. They're insulated because code requires ducts to be insulated even in conditioned space so they won't sweat, and minimum R6 for Energy Star is required for one of these homes. So one of the things that we try to do here is reduce our duct static pressure as much as possible. And so we used to just put a box with a collar in the bottom for our returns, but for this main return, what really helps us out is if we spend just a few more dollars and have the sheet metal shop make a rounded 90 instead of just a box with a collar on it. That's going to reduce our return static pressure significantly. So the trunk that you see here is not a supply or a return trunk. This is a jumper duct trunk. So each one of these bedrooms, instead of having a dedicated return and all the duct friction that gets associated with that, we have jumper ducts. And so the path for a room pressurization to get equalized is right there out of that jumper duct. That goes into a trunk, and all these jumper ducts tie together into a main 14 by 14 right here. So this is going to provide a path so that our air can get from each room back through this grill here into the return that we ran. That's a very short return. It's on the same side of the house as the equipment is. And so all this is translating to lower duct friction. Now you'll notice that there's a good amount of flex that's been ran. And a lot of guys are against flex, but really the performance of straight flex versus straight rigid ductwork is almost negligible. You'll also notice that our supply branches are very short. We're not taking them to the perimeter of the house like you would normally see. So we're keeping duct static very low doing that, and I've actually oversized by an inch all of my flex ducts just to keep that friction low. A high performance house does not need your supplies to be up against the exterior wall. That's old school mentality where you had single pane windows and not a lot of insulation in the walls. High performance home is well insulated, well sealed. You just get the air in the room with the shortest route possible, and you save a lot on duct static. Instead of running 100% rigid duct trunks to flex branches, we use sections of rigid duct, and then we hook up our flex branches to them. We'll reduce down a size, and then we'll run a straight piece of flex over to another section of rigid duct, and we repeat the process until the end of the line. And that saves on labor and materials, and it doesn't sacrifice in performance. A lot of people are opposed to using flex, and it's true that flex, when not ran correctly, does create problems. It has a lot of potential friction related friction loss and high static pressure if it's not done right. But what we've tried to do is take certain measures to reduce our duct friction, like the rounded returns, making sure we use elbows instead of bending flex 90 degrees, oversizing our duct in some places, All those things reduce the amount of friction that our duct system has so that we can afford to have a little bit of flex in this system, and we can use up some of that friction there. So again, is this the most energy efficient system or duct system ever made? Absolutely not, but it gives us great performance and great bang for the buck. So as we go into the crawl, some of our risers that feed our supply and return to the second floor, if you notice, we've used hard 90s, where sometimes we might be tempted to use a flex to make a sharp 90. Everywhere we can in this house, we try to use a hard 90, and then we'll transition to flex after that. That does a tremendous amount of reduction in duct static. So this is going to be a condition crawl when it's all said and done, which is something that, again, is very important to the builder, that keeps the humidity levels in the house and the crawl space down, and it just makes for a nicer home. And so because of that, we don't want, if there's a condensate leak, for it to fill up here in the liner, because you're just going to have a swimming pool if that happens. So if you notice, we've hung our unit, we've got it in a drain pan, we'll have condensate safety switches, and all is that an effort to keep that any kind of flooding or moisture problems in the crawl space to a minimum. Okay, the builder is dead set on using natural gas for heating, even though in this kind of house a heat pump would do very well. He just wants to keep things consistent, which is fine. So we've got a 96% two-stage furnace, and it will be paired with a two-stage 16 SEER 3-ton AC. Now again, normally in these houses we would have put a 2-ton AC in here, but because of some of the material choices that had to be made, it bumped up our load closer to 3 tons. But again, he's paying for a two-stage 16 SEER unit. That's something that's very important to him. If you notice, we've got excellent filtration here. We've got a MERV 11, which can also be upgraded to a MERV 13, and that is an oversized filter. It's bigger than the furnace cabinet, so it's going to slow that air down and allow it to have more dwell time across the filter. So those little measures there don't cost a lot of money to do. I selected an oversized evaporator coil for the latent capabilities of cooling. So we could have gone with a 17-inch cabinet matching coil that would match the size of that furnace, but we stepped it up to a larger evaporator coil. We still have an AHRI matchup, but it's still 16 SEER, but again, we just get a little bit better latent performance out of our system. We try to keep the duct liner to a minimum and try to wrap all of our ducts. That's just going to improve your indoor air quality and decrease the amount of fungus and all kinds of other pollutants that are going to stick to that insulation liner and cause indoor air quality problems down the road. And of course, we are using a ventilating dehumidifier from Santa Fe. This is the old Ultra Air line. They've now combined them, and so they have the Santa Fe Ultra line. This is a 98 pint. We've got a fresh air duct with a damper that's right here, which will bring in fresh air. It'll mix with return air, get dehumidified, and then get supplied back into our supply plenum. Duct sealing is critical with a high performance home, especially if you want to get a really good Energy Star rating. So we're really careful about making sure that we mastic the inside and the outside of ducts to really create a great seal. Duct leakage by code is supposed to be under 5%. Typical house that we do, we strive to get under 2% duct leakage. So we've already passed our rough-in inspection, but we do need to come back and insulate some of the exposed pipes that you see here, and we've got, you know, some trash to pick up. So we've got another half a day or so left out here. We're going to come out tomorrow, finish up, get the panel back on the furnace. That way no critters can jump in there between now and the trim out phase. But a lot of companies do not take their rough-ins this far. You know, they're just going to run the bare minimum, whatever's going to get covered up, then they do the rest on the final. We try to take our rough-ins absolutely as far as we possibly can. In case we have any issues with our ducts, everything's exposed. We do our duct test right after the rough inspection, so that if we do have any leakage and those ducts are going to be hidden behind walls and sheetrock, we can fix it right there and then. And we go ahead and install all of our equipment, run as much of our piping as we can. That makes the trim out a lot easier. So again, the purpose of this video was just to show how you can implement certain high performance measures pretty cheap and not blow your budget way out of the water. There are a lot better high performance homes out there, but they're operating on much higher budgets. We really can put in one of these systems for just a couple $1,000s over a typical system built to code, and ours performs so much better. Our ducts are tighter, our static pressure is lower, our SEER is higher, and the delivered capacity is right there close to design. So hope you learned a little something here. If you have any comments or tips that maybe you've learned out in the field that help to increase the performance of a system, leave them in the comments below. Thanks for watching.